Hello and welcome to our Open Science 2021 event organized by the Young Academy of Slovenia in collaboration with the Ministry for Education, Science and Sport of the Republic of Slovenia. Pozdravljeni in dobrodošli na dogodku Odprta znanost 2021, ki ga že četrto leto zapored organiziramo Društvo Mlada akademija v sodelovanju z Ministrstvom za izobraževanje, znanost in šport Republike Slovenije kot del meseca znanosti. Nadaljevala bom v angleščini, ker imamo gostjo iz tujine. My name is Ana Slavec and I will be moderating this discussion as one of the two Slovenian Eurodoc Open Science ambassadors and member of the Young Academy of Slovenia. I would like to introduce our guest, EOSC Engagement Manager at Geant, the Trans-European Research and Education Community Network, and the member of the Board of Directors of the European Open Science Cloud. She is an information professional with more than a decade of experience working in the research data services in the higher education sector. At the Digital Curation Centre, she led the DMPonline services and worked on consultancy and training. The topic of the webinar today is the support for FAIR principles within the EOSC. So her name is Sarah Jones, and at the end of her presentation, there will be a discussion. If you want to ask questions, you can do so by using the chat. Now, Sarah, the floor is yours.
Excellent. Thank you very much, Maya, and thank you all for the invitation to speak today. So I'll just bring up my slides. As Anna said, I'm Sarah Jones and I work at the Geant Association based here in the Netherlands. And I'm also involved in EOSC, which is the European Open Science Cloud, and I'm on the board of directors for EOSC. And what I've been asked to speak about is how we're supporting FAIR within EOSC. So I want to begin really by just giving an introduction to these topics. So to explain what EOSC is, how it's developing, what the underlying vision of EOSC is, and also what the FAIR principles mean. And then from that, I'll go on to talk about how you as a researcher can make your data FAIR and the role for different support services in enabling FAIR. And then I'll come back to the topic of EOSC and look specifically at some of the support services that are becoming available through EOSC and how they can help in your work as well. So first off, an introduction to what EOSC and what FAIR mean. So the European Open Science Cloud is an initiative that's been led by the European Commission. They've had a number of programs of activity, funding different projects to build the EOSC. And it's really a platform or a support service to enable researchers to engage in open science. So what we're doing within EOSC is trying to develop this web of FAIR data and services. So all of the content that you produce within your research and you make available to others, one of the underlying objectives from the European Commission is that we make that content fair and open, and that we aggregate that together so that it's easily accessible to other research communities and it can be used in different contexts from the original creation. So within EOSC, there's a lot of infrastructure, and I think in earlier webinars, you've heard about the infrastructure in Slovenia. What we're doing at the European level is trying to federate those different e-infrastructures and research infrastructures. There's typically a kind of cluster project or a thematic research infrastructure in many different domains. You may have heard of some of these like ENVRI-FAIR or EOSC Life or PANOSC. And we're trying to bring those together with the e-infrastructures, which are the kind of cross-cutting underlying services like the network, like the persistent identifiers and the access layer to data. And by doing so, we're building this environment in which you can bring together the different data and the services to make it easier for researchers to perform their different analysis and address the societal challenges. So you can see a very basic diagram. The EOSC core is the kind of the underlying services that are needed to make EOSC work. And then we're having a cross-search, a federation of all the different data. And the EOSC exchange layer is where all the services can be accessed. So you can get different tools for your storage and your analysis and for publishing data so that you can do the work that you need to do. So one of the core objectives of EOSC is to enable multidisciplinary discovery and reuse. In many cases, researchers are having to go to different services. You may be having to go to different catalogs or repository services to browse for data, and then bring those together manually yourself. And within EOSC, what we're wanting to do is to avoid that kind of disconnected silo of all these different services and different locations, and to federate them so that when you're engaging in the EOSC platform, everything's connected up and you're able to access the data and the different tools you need from one place with your one kind of single sign-on, like your institutional credentials that you use. And a big part of that vision relies on FAIR. So FAIR is really central to the underlying principles in EOSC. And we describe it as the glue that's allowing us to connect the different data and services together. And you can see how we've kind of put this interoperability framework, which is based on FAIR, as a kind of layer in this overarching diagram. So the Commission has policies when it funds research projects that it expects researchers to make their data fair and as open as possible. And by doing so, it allows us to connect up different data sets because we can have crosswalks between different community standards. And within EOSC, we're trying to address all of the different outputs of research, not just the publications, but the data, the different software that you've used for your analysis, and also bringing together those different services that you need to undertake the research. So that's a very brief introduction to what EOSC is. And as I said at the start, I'll go into some of the functionalities and services within EOSC later on at the end of the talk. But I now want to just explain a little bit about what the FAIR principles are. You may have heard of these before. It's quite a well-known term now, but FAIR stands for making things findable, accessible, interoperable, and reusable. And it's a set of 15 principles, really things that you do with your data to ensure that those data are shared in a way that enables both humans and machines to find and access and reuse them. So the standards are really quite a central aspect of FAIR, and that's to make sure that things are understandable by the machines as well as humans, because we're able to interpret what the different values mean. So these are the FAIR principles. There's principles around the findability of data, making sure you assign persistent identifiers. So we have a kind of unique identifier for the particular data set, which helps with discovery and retrieval. It also helps in kind of disambiguating data. You know, you might have multiple things from one provider or things with a similar name, and we're then able to identify what exactly is being referred to. And those identifiers also help in other ways with citation of data and tracking the use and the impact of the data. The accessibility is really about getting access to that content. So making sure that the data is retrievable by its identifier, and that the protocols we use for accessing and downloading the data are open protocols and they're universally implementable. And I think an important aspect of FAIR is that it doesn't mean the same as open. I'll touch on this in a moment, but you can see the principle here, the protocol for access allows for authentication and authorization where necessary. So you can have things that are closed or only shared to a particular subset of users, and they're still FAIR. And then I think for research communities, the interoperability and reuse principles are the ones that are the most important, because this is really about making sure your data is understandable to others. So you're properly describing your data, you're using relevant standards and controlled vocabularies to do so, so that that data can be understood by others in your community and potentially in other research communities as well. And when you make your data available, you have to think about how that's being shared, things like the usage license, making sure that it's shared with all of the context needed to be understood. Now, One resource I wanted to flag, which I think is very useful when you're trying to engage with the FAIR principles, is this FAIR data principles explained by the Dutch Tech Centre for Life Sciences. And what this does, it takes each of the principles and it goes into detail on what exactly that means and how it can be implemented. And I'll give you an example of that just here. So one of the reusability principles is that the data and the metadata are richly described with a plurality of accurate and relevant attributes. And really what that means is that you're giving your data many labels. You're not just giving it a file name, a title. You're making sure that all of the aspects of your data set are properly labeled. People know how things have been measured, what any abbreviations in your data set mean, and you're using relevant standards and terminologies for this so that it's understandable to others. So it's going much beyond the discovery to the actual reuse of that data. And by plurality, they're really just saying that you should add as much documentation as possible to make sure that data can be understood and reused by others. So be generous in terms of the context that you provide and all of the labels that you give when you're describing your data. Now, a couple of final points on FAIR and also putting FAIR into the context of open science and data management. One thing I'd stress is that FAIR isn't really anything new. Many research communities have been engaging in the kind of practices that the FAIR principles advocate long before these principles emerged. They only came out in 2016. But I think the real strength of FAIR is that it's a very meaningful and memorable articulation of those concepts. We naturally all want to be fair. And I think this is also why it's been picked up by research funders, because it's something that is understandable to research communities, and it's something that people want to adopt. And as I mentioned before, fair and open don't mean the same thing. If you're doing work with the European Commission, you'll see both come up in their policies, and they advocate for data to be fair and open. So ideally, we want both of these. But as I mentioned before, you can make your data fair and have it kind of restricted to a certain community or to certain, have it under an embargo for a set period before it's made available. So it doesn't have to be under an open license and available to anyone for any reuse. And both of these concepts apply on a scale. So you can make your data more fair, you can make it more rich by adding more documentation and description, by applying more of the principles. And the same with open data. There's a concept of the 5 stars of open data. At a very basic level, to make something open, you just need to make it openly available under an open license. But that data may not be very reusable. So you want to make sure it's in a good file format that others can reuse, that it's properly labeled again, and that you're using concepts like linked open data to make sure it's reusable by others. So both of them are on a scale, and really what you'll see in different funder policies or through support from your institution is that you'll be encouraged to be open and fair where possible. And the final concept I wanted to bring in this section really is data management as well, because I see this as really the bedrock before you make data open and fair. Obviously, when you're undertaking your research, you have to think about how you're storing your data, who you're sharing it with, how you're going to create it, how you're going to capture all that documentation. And all of those decisions and all of those practices you put in place help you to do your research and to make sure you have the right version of your data at the right point. And it also enables you to then make sure your data are reusable by others when you choose to make them available in an open or fair way. And I think the difference really is that data management is much more of a kind of primary concern. It's beneficial to you as an individual researcher, whereas open and fair is about sharing with the broader community. So there's a kind of more external community benefit there. There's certainly incentives for you as researchers too. And I think in earlier sessions, you've heard about recognitions and rewards for engaging in open science. There are studies that show increased citation rates when data is made available. So there's definitely benefits from being open and fair. But I think I wouldn't underestimate the value of managing your data in the first place very well, because that will enable you to engage in these principles more easily. So that's some introductory remarks about what EOSC is and what FAIR is. And now I'll move on to thinking about how you as an individual can engage in FAIR data, how you can ensure your content is available to others in a fair way. And the first thing I'd stress is that you really want to plan this from the outset of your research project. Many of the decisions you take early on in your research will affect how easy it is to make your data available or how reusable those data are by others. And you'll see many funders ask researchers to create data management plans. And this is a big part of the reason why, because if you plan from the outset, then it's much easier to make the content available at the end. And some of the things you need to consider about what file formats you'll use, for example. Some file formats, they're proprietary. Other people may not have a license to the same software, so they may not be able to read your data. So you want to use open formats where possible, or to convert your data to an open format if you're sharing it. And obviously some file formats are kind of higher quality, like if you're doing an audio recording, particularly if you're wanting to preserve and share this, you want to make sure you capture it in the highest quality and to make that content available. You also need to think about how you're going to describe and document your data, what standards and controlled vocabularies you'll use here. That's really important to think about early on, because you want to build that into your process of creating your data. Because if you don't capture the metadata as you go, then it's a lot of work and you may not actually remember all the details later on. If you're working with human subjects, you may have consent agreements to collect the data for your research project. And those consent agreements also need to cover the potential reuse of your data too. So if you're wanting to make your data available and deposit in repositories, then you need to also make sure you have permissions to do that. And that may mean that you have to engage in other processes, anonymizing or de-identifying the data or aggregating it so that people, their identity is protected. But that's something you want to consider in your agreement, because otherwise you won't have the relevant permissions you need in the later stage of the project. And then when you're thinking about the sharing, you need to think about where you want to share, what repository is most suitable for your data, under what license are you going to share the data. And in one of the projects that was supported through EOSC, we developed this FAIR data checklist, which takes the 15 principles of FAIR, and it really frames them in terms of actions for you to be able to check, whether your data is findable or accessible or interoperable. So do you have a persistent identifier applied to your data set? And is there metadata online that can be searched and harvested by other services to make it more discoverable? And what we found when we've used this is that often people find it a lot easier to engage in the findable and accessible sections, because a lot of services will support with that. The interoperability and reuse are the harder aspects of FAIR to meet, because they're all about adopting the standards, and not every community has standards in place yet. So sometimes there's more work to be done there to help develop those standards and then implement them. And the other aspect of FAIR that I think is really important to recognize is that it's a joint responsibility. It's not something that's just for you as a research community to address. If we want data to be fair, then we need services that enable FAIR too. So there's a big role for the research institutions, for the different research infrastructures, and for bodies like EOSC, and also for funders to support these services. And if we look at the 15 principles, I've tried to put in bold here the different roles in implementing FAIR, and many more really fall on the support services, because it's making sure the infrastructure enables the data to be found and harvested and reused. And really the key roles for research communities are about that interoperability and reuse, so adopting the standards and cross-referencing the different resources. So in terms of the researcher role for FAIR, I think the most important thing you can do is adopting the relevant standards as you create the data. So look at what metadata standards are available in your field, look at what different controlled vocabularies or ontologies are available, and adopt those when you're creating your data. And there are many registries of these out there, resources like FAIR Sharing, which is a catalogue of different standards you can use, or there's a metadata standards catalogue looking at different disciplines available through the Research Data Alliance as well. So when you're creating your metadata and documentation, make sure it conforms to those community standards, and make sure that you also explain the broader context that you're working in. So the provenance of your data. Why was this data created? What was the research question you were addressing? How did you go about implementing that question? Did the data capture maybe change in different phases of the research because of certain things that you discovered? So you want all of that context so somebody can understand your data and also know that they can trust in it. And then you want to make sure that you properly license your data. Again, there are various tools and services that can help with this, that explain, the different aspects of Creative Commons licenses, the different conditions that are on reusers, or licensing wizard tools that I can provide links to if desired, that can help you pick a relevant license for your data and for your code. And then you want to cross-link all of your different resources. So when you're sharing your research outputs, don't just think about the publication, make sure that's linked to the data and to the code and to anything else you need to make available, like your workflow, that others may also want to reuse in their own projects. And then I think the other key thing for research communities to do is to choose appropriate services. And I'll provide some advice on this. You want to look that those services help enable FAIR, that they assign the IDs, that they're making the metadata accessible to others so it can be harvested and placed in broader catalogues and indexes, and that they're using all of the standard protocols for things like the access. And I mentioned before that not every research community has its own disciplinary standards. So I think if your community's lacking standards, it's good to try and engage in that broader discussion to develop the standards that are needed, or the controlled vocabularies. And there's work happening in different fora around this. The Research Data Alliance, for example, has an ambassador program, a grant scheme that's open at the moment. So you can be an ambassador for open science in your community. And there are funds available to help you do things like develop standards or to improve the tool sets that are needed in your space. And I think that's one good way of trying to help foster some of the work that might be needed to help you implement FAIR. In terms of the institutions, one of the key things for them to do is to raise awareness of the relevant standards and the practices that can be adopted for FAIR, and to help researchers find appropriate data services. And these may be disciplinary data services within the community that you're practicing, or there are various institutional services. So many universities, for example, will run repository services to share data and to make it available to others. And where they do run these kind of services, then again, it's very important to try and make sure those services are picking up on the FAIR principles. So they're assigning identifiers, they're referencing those IDs in the metadata record, and making that metadata available in a harvestable way. And there are various tools out there to assess repository services for fairness, to see how well they comply with the principles and how well they make content available in a fair way. And this is something that is useful for institutions to try and improve the practice of the services that they run. And I think The other thing that's really important within research institutions is providing local support. One of the approaches we're seeing being picked up quite a lot within the Netherlands is this team science approach. So making sure research communities have support staff that are working closely within those research teams. So there may be software engineers or there may be data stewards who kind of partner with the different research groups. And all of those inputs are really needed to undertake the research and to make sure it's made available in a fair way. Now, just to close on these examples of how to be fair, I wanted to just reflect on a couple of different disciplines and how they've engaged with the FAIR principles. So DOBES is a group that was documenting endangered languages. It was set up in 2000, and they were going out, they were doing recordings of different languages and capturing those so they could have a historical record of those. And the DOBES community, when they were first setting up this project, adopted a number of principles. This predates the FAIR principles being articulated, but they had actually picked up on very similar concepts. They knew that it was important to identify the data so it could be properly discovered and reused. And they also put a big emphasis on digital preservation, because obviously these are endangered languages and they wanted to make sure that those recordings were captured and were stored and preserved for the long term. And you can see on the right-hand side of the slide the principles that they agreed to as a community to follow, that they were applying persistent identifiers, that all of the individual research objects, whether they were kind of transcripts of recordings or the actual audio recordings, they should all be accompanied by metadata, and that they had a number of standards they were using for that metadata. And they had a structured catalogue so that they could properly search across all of these different outputs. They also interestingly said the data should be openly available by default, unless there's good reason to keep it closed. And as I mentioned, they had a strong emphasis on digital preservation. So they had recommendations on the different data formats that should be used to make sure the content was rich and high quality and could be preserved. And they also used trusted digital repositories so that the content was kept available for the long term. And then the second example I wanted to give comes from the International Virtual Observatory in astronomy. And again, this is a community which is really self-organized to make sure that the content is made available openly. So within astronomy, there's a lot of community agreements that as soon as content comes off the telescopes, it's made available to the community at large. And they did a lot of work developing what they call an interoperability framework at the international level, so that they have a set of standards and common formats that everybody's adopting, so that they're able to make that data findable and reusable in different contexts. And I think because they've been very strong in doing that and advocating those standards, that's been picked up by the community and the service providers at large. So the different telescopes, the different disciplinary data centres have all adopted this kind of set of standards and interoperability frameworks that have been developed. And a big part of that was agreeing a kind of standard for the different observational data they were capturing, which is called FITS, the Flexible Image Transport System. And that brings together the data with the different metadata so that that's one package and more reusable. And the VO kind of acts like an interoperability layer. Anyone can publish data to the virtual observatory, and kind of like EOSC, there's a suite of different tools so that you can access the data and have the tools to process it through the observatory. So this is a couple of examples of how different communities have self-organized. And I think if there isn't already a kind of culture of fair practice in your research community, it's good to have those discussions at your disciplinary conferences to try and think about what needs to be developed to enable FAIR in your field. And there are lots of different organizations like the Go FAIR Foundation, for example, that runs a series of metadata for machines workshops and helps people develop FAIR implementation profiles and FAIR data points so that you have the kind of set of tools you need to implement FAIR in your community. So the final thing I wanted to touch on is how EOSC can help in this field. And as I mentioned before, EOSC is really a platform that's bringing together all of the data and different services that you can use. And there are many tools available through EOSC. You can browse the EOSC portal and find tools for discovery or data storage or compute or different analysis tools. And I wanted to flag one. I mentioned before the importance of data management. One tool you can access through EOSC is DMPonline, which is a tool for data management planning. And this helps you think about how you're going to organize the collection of your data, the processing, and the ultimate sharing of that data. And many research funders require data management plans. So there are templates in the tool based on those different research funders. So if you're applying for a European Commission project, for example, you can use the EC template or other national funder templates. And there's also guidelines in the tool. There's best practice guidance that can help you understand the different options for storage or licensing. And there's practice from institutions. Many institutions have customized the tool and provided details about the local support that they offer. So you can get details about what's available through your community or through your research institution. There's also options within the tool to get feedback on your plans. So you can submit it for review and get some tips and advice on how to improve. And there are also options to publish or to share your plan with others. So you may want to share it with research collaborators to co-develop the plan, or you'll see here there's the public DMPs. Under this page, you can find many plans that have been made available by others, and that may help you look at what's good practice in your field. And as with many tools, DMPonline has connections with related tools in the research kind of pipeline. So it has connections with lab notebook tools. So you can take your plan and you can export that into your notebook and pull in the relevant details around the practices for how you're going to process and store your data. And it's also connected to repository services like DSpace and Dataverse. So if you're going to publish your data, you can publish it with the DMP, with your lab notebook, and connect up all of these different outputs. So that's just one example of a tool that's available through EOSC. There are many more, and I encourage you to go and look at what's available. The other things I wanted to flag in this section are some of the functionalities that are being developed largely through the EOSC Future project, which is a big infrastructure project that's been invested in by the Commission to bring together the research infrastructures and e-infrastructures. And as I mentioned before, one of the key aims of EOSC is improving the discovery of data. And there are many catalogues out there already from different research communities, like the CESDA catalogue in the economic and social sciences, or generic catalogues like UDAT, which cover a range of research disciplines. And what's happening within EOSC is that we're developing kind of common profiles for the metadata so that we can have a cross-search across all of these different catalogues. So that improves the discovery. And there are other tools that are being implemented. So artificial intelligence is being used to make recommendations for you. So based on the type of data you're working with or your field of research or the different characteristics of your user profile, so where you're based and your discipline, we can make recommendations on relevant data sets and services for you. And this is something that's an enhancement coming to the EOSC portal through the EOSC Future project. Another aspect they're looking at is knowledge graphs to cross-link all of the different research outputs. So to link your data with your publications, to show the context in which that was created, to show your different research collaborators, so you can see the kind of fields that you're working in, the different organizational affiliations and related areas of work. And I think the knowledge graphs is an important technology really to help with impact and citation. You can see all of those different connections. You can see where different research outputs are being picked up, and it helps to kind of browse what's available. And I mentioned before the importance of repositories for sharing your data. There are many repositories that are being federated into EOSC as a platform. And there's a very useful catalogue of different repositories in different communities. So Re3 Data is the registry of research data repositories. And when you search, you can do like a general search for a particular name or country. There's also a series of filters you can apply, and you can look at the different repository features. So whether the repository is open access, or whether it assigns identifiers, or whether it has a certification if it's a trusted digital repository. And these different aspects are important for making sure that your content is made available in a fair way, but also to help with the citation of your research and the broader discovery of it. And when we have trusted repositories, they're typically also curating and preserving that data for the long term. It's not just about making it accessible, it's making sure that it remains accessible over 10 years and more. The other thing that's really key within EOSC is that you can get access to free compute and support resources. And there's a number of projects that have been funded that provide access for different research communities. So Seascale and Reliance both work with either Copernicus data or in the kind of Earth observation fields. And they're making available different storage resources and cloud services for high performance computing. And you can see there's a huge amount of resource that's made available through these. They're also applying different technologies like data cube technologies that you can get access to. And they have, through the EOSC portal, you can find the different services and apply for either an amount of storage resource or computational hours. DICE and EGIACE offer similar services, but they're not limited to one disciplinary field. And OpenAIR is an open science project. And within OpenAIR, they're making support available to help you engage in data management planning and making your content openly available and fair. So there's kind of more human support rather than technical support available through OpenAIR too. And as I mentioned before, the link at the bottom here, the marketplace for EOSC, is where you can access all of these different services. So I think there are various benefits for you both to engage in FAIR data, because it helps make your content more openly available, more reusable to others, helps increase your citations. But I think within EOSC, there's lots of benefits because it's providing a platform that enables your research. As I mentioned before, there's single sign-on to a variety of resources, so you're able to use your common institutional credentials. You're able to access various services for storage and analysis and sharing of data, and access those support options for engaging in data management and open science and FAIR too. And ultimately, by using platforms like EOSC, it's helping connect you with others in your research community and enabling kind of broader collaborations. So I think it's helping kind of get more impact from your research and helping you connect up to others. One final thing I wanted to flag, a lot of the developments I mentioned in those final slides come from the EOSC Future project. And EOSC Future also has a user group, which is a way that researchers can engage in EOSC and can provide feedback on what's being developed. So we're wanting to try and understand the ways in which you're creating your data, the tools that you need, potentially if you need different commercial tools or access to paid for data sets. These are things that can be procured and made available through EOSC. And also, as we develop new functionality and services, we're wanting to test that with research communities to make sure it fits your practice and that it works well for you. So we have around 300 researchers in the user group so far, but applications are open for more. So if you're interested in getting involved in EOSC and providing feedback, then by all means apply to the user group, and we'd be very happy to test things with you and to work with you and help you get more from engaging in open science. So that was my final slide. I'll just stop the share. I'm very happy to take any questions or engage in discussion around open science and EOSC and FAIR.
Thank you, Sarah. That was a great presentation of FAIR principles and EOSC. Now I will read you a question that I have received in the chat. And so those who are attending, you're still welcome to type in further questions. So the question we received is, researchers are usually reluctant when they hear they should put a lot of effort in managing their data and making it available for others. What would you say to researchers who understand the idea of open and fair data as only additional work for them? What initial tools and links would you suggest when you buy into interoperability and making data reusable?
Yeah. So yeah, I think this is a very valid concern that it is additional work. When you document your data, there's a lot of work that goes around capturing all of that additional metadata and documentation. So it's adding more to your workload. It definitely is. But I think I'd think about it primarily as a benefit to you individually at the start, because if you document your data well, when you come back to it in 3 or 5 years' time, it's a lot easier for you to reuse. So doing that is actually a benefit to you as an individual. And then if you make it available open or fair, then there's this broader community benefit as well. Others are able to do things with your data that maybe you don't have time to, or you hadn't envisaged a certain reuse. They may use it in a completely different context, and you're still getting credit for that because it's your data that's being reused. So you're still getting the citations and the impact from that and from those further reuses. So admittedly, it is more work. And I think looking at the benefit to you as an individual first helps make that a bit easier to invest in. And then thinking about the kind of track record and the potential recognitions and rewards you get, make it easier to think about that open sharing. In terms of resources to look at as a starting point, there are lots of kind of practical how-to guides. There's some nice resources. I'll drop one in the chat from the UK Data Archive around data management, a kind of short guide which helps you understand the basic principles. But I think it's really good to look at the community resources. So engaging with the different research infrastructures like CESDA or EOSC Life and the tools they have. Many have training courses that will look at the particular tools you're using, or they'll have details around the different community standards and kind of tools that can help you automatically capture that metadata, because the more that's automatically done, the easier it is to engage in as well.
Thank you. I have a few follow-up questions. So there are many differences between scientific fields in how well the data infrastructure is developed, how metadata standards are developed, so what is the available infrastructure for researchers. So what would you advise to researchers who work in fields where they don't have so many available services so far?
Yeah, so I think where there's a lack of services in your discipline, I would certainly look to your research institution. So many research institutions have some kind of data management or support unit, typically through the library. They may have some local services like the repository service, or there are also generic services. So through EOSC, I mentioned some ways you can get access to storage and compute or different repository services. Some of these cater for all disciplines. So I think there is always some support out there for you if there's not already the practice within your field. But I think it's also important to raise that discussion within your research community, because we want to engage the long tail of science and to try and help everybody kind of increase their FAIR practice. And as I said, the biggest part for research communities there is developing the standards. So if there aren't standards in your field, I think that's an important thing to also raise reason to try and start the discussion on.
And since, so much effort is put into making data available to other researchers, the statistics about data reuse are showing that a lot of data is not being reused. So within EOSC, there are initiatives to increase the reuse of data so that more researchers would make use of already available data resources, so of data that is already deposited.
Yeah, so I think the way that EOSC is framed, the kind of tools that are being developed to increase the discovery will help with increasing the reuse, because I think part of the issues people have had is that they don't know where to search for the data. So there could be relevant data, but they're not finding it. And then they're going on to recreate similar data sets. But also the European Commission supports things like the mission projects, which are looking at reuse of data in different contexts. So I think, again, that's going to increase the reuse of existing data by bringing together different research communities to address those kind of broader societal challenges. There are some funders, not the Commission directly, but other funders like NIH in the States and GISC have done programs called Digging into Data, which is specifically around encouraging reuse of existing data sets. So I think there is also a trend to try and promote the reuse of existing resources, not always creating new data.
Okay. Sarah, thank you again for being with us and answering our questions. This was the last event in our Open Science 2021 series. You can watch the previous events on our YouTube channel. Thank you all for attending. I hope you found the event useful. Now I will switch to Slovenian to conclude today's event in my mother tongue. I wish you a nice rest of the day and goodbye. Torej, hvala vsem, ki ste nas poslušali. To je bil zadnji dogodek v nizu Odprta znanost 2021. Na prejšnjih dogodkih smo obravnavali spodbujanje in nagrajevanje odprtih znanstvenih praks, odprt dostop do raziskovalne infrastrukture in odprto strojno opremo. Kot ste slišali, si lahko prejšnje dogodke ogledate na YouTube kanalu Mlade akademije. Več informacij o društvu Mlada akademija najdete na naši spletni strani www.mladaakademija.si, kjer se lahko naročite tudi na naše novice, da boste obveščeni o prihodnjih dogodkih. Smo tudi na Twitterju in Facebooku. Poleg z odprto znanostjo se ukvarjamo še s številnimi drugimi temami, ki so pomembne za doktorske študente in raziskovalce na začetku kariere. Če vam je všeč naše delo, nas lahko na koncu leta podprete z donacijo dohodnine. Možne so tudi neposredne donacije na TRR. Tistim, ki nam nakažejo vsaj 20 evrov, podarimo brezplačen dostop do orodja za urejanje angleških besedil Instatext v vrednosti 100.000 znakov. Hvala vsem, ki ste že ali še boste donirali. Vsem želim prijeten preostanek dneva. Videnja.
Thank you. Bye-bye.
Thank you, Sarah. Bye-bye.
Bye.